Hi HashiConf. It's hard to believe it's been 6 months since Boundary was released. Boundary launched in October of last year as an open source secure access management offering focused on enabling identity-based access controls for dynamic infrastructure for human users. Today, we'd like to talk about the enhancements that Boundary has made since launch, where we're headed, and how Roblox has started their Boundary journey to enable secure access to their global infrastructure. Before going further, let's do a couple of quick introductions. My name's Pacent, and I'm part of the Boundary team where I'm responsible for product management. With me today is Senior Roblox Site Reliability Engineer Charles Zaffery, who's one of the lead staff with ensuring the availability and security of one of the world's largest online experience platforms. Charles, take it away.
Thanks, Pete. My name is Charles, and I'm part of the orchestration team here at Roblox. And by orchestration, we mean orchestrating everything above the OS and below the application itself. So today we accomplish that with a combination of Nomad, Consul, and Vault. I think you'll hear it popularly referred to as the HashiStack. And we also utilize everything else that HashiCorp uses from Packer, Vagrant, Terraform, and so on. And so we're really looking forward to how we can implement Boundary within our infrastructure. Roblox is an experience-focused platform for the metaverse. This means our players can create almost anything, from clothing and body parts for your digital avatar to a diverse set of experiences, from action-packed first-person experiences to amazing concerts to outlandish fashion shows. Roblox has 200 million monthly active users with over 3 billion monthly hours of engagement. And we do all of this with an SRE team of about 6. So today, that SRE team manages Nomad, Consul, and Vault for over 20,000 nodes across over 20 clusters, serving more than 600 internal developers. So today, for Boundary, one of our problems is that out-of-country folks need to access private infrastructure. Now, this includes everything I've just talked about for Nomad's control plane, Consul's control plane, Vault for secrets for both reading and writing, as well as various different databases and caches. Today, one of our big challenges is how do we get access to Redis? And so some other challenges we have in there is that we need multiple access levels depending on who is accessing what. Today, we do it primarily through VPNs. They are completely static, but they're a little difficult to automate. So we're looking at bringing ourselves into today's solutions with Boundary. Let's talk about where Boundary fits into the picture. HashiCorp builds identity-based tools to automate the various workflows in the application delivery lifecycle. One of the workflows in that lifecycle is that ultimately humans, whether developers or DevOps engineers, are going to need access to their app's infrastructure. That's where Boundary comes into the picture. So today, Roblox relies heavily on Vault and Consul for discovery and security. However, these solutions are primarily focused for usage within an operated and owned network. Our use cases also today are almost entirely used by machines. Humans can access these tools, but there's still a pathway of tooling they need to have access to and already be authenticated before they can even get to them in the first place. So talking about the future, as Roblox expands our footprint and brings on individuals from all over the planet, we want to have our developers and operators to have total security with the ability to react to new situations and develop new software as fast as possible. So something that gets me really excited about Boundary is that it's a new open source entry into the dynamic network security world. Not just open source, but it's very simple to understand at an infrastructure level. So it's just a normal web application with a client and a server backed by a Postgres database. So that makes it easy to run, and it's also elegant to use. Not just elegant to use, but it's an elegant solution to a hard problem. Another thing that really gets me excited is the integration with all of our existing tooling today. So I mentioned Terraform here, but on the roadmap is also Consul for service discovery and transient secrets for backend services through Vault. The local development story is also really good. It's the same dev flag that all the other HashiCorp tools have, such as Nomad, Consul, and Vault. It just makes things like developing local Terraform an absolute snap before going to production. So some of the key benefits that we get and key requirements are that they sync with our existing IDP. So that's already there today. Another thing is that we can configure everything with infrastructure as code. that being Terraform for us, and ideally have dynamic targets through Consul, which you can do today with Consul Terraform Sync. Another thing that I like is that it has a really nice GUI, and it's very programmatically friendly. So to give an example, one thing that I do for a lot of local development is I just pipe a curl into Ruby, parse it as JSON, and if I can't do that, I don't want it. So one thing is that it needs to be so easy that you can't not do it to access resources behind firewalls, and Pete's going to talk a little bit about that.
Thanks, Charles. And in talking through this scenario, it became really clear that this closely aligns with our vision for Boundary as a whole. That vision is an ephemeral model of access in which users can authenticate to Boundary using their identity provider of choice, and then have granular role-based access controls that authorize what actions they can perform on those targets. One of the key ideas with this is that when users go to access those targets, the configuration of address and connection information is automated by Boundary. That way, users aren't stuck having to manage brittle information like IPs and ports and credentials that they need to securely connect to those targets. And in having Boundary automate this configuration, that access information can be managed on a just-in-time basis, so that even if that connection information was to be compromised by a malicious entity, there's time limits in terms of how long those are valid and exploitable. And this leads me to why we think Roblox's use case is one of the canonical examples for the value of Boundary. The idea here is that Roblox can use Boundary's role-based access control to establish identity-based access for any infrastructure target. They're able to delegate to Roblox's preferred identity provider via Boundary's OpenID Connect authentication method. In this example, we'll use Azure Active Directory, but Boundary supports other common IDPs like Keycloak, Okta, Auth0, and others. On top of this, Charles will use Consul and Terraform to automate target configuration info. This is a powerful paradigm where Boundary can lean on external mechanisms to manage the networking of target discovery and environment configuration. Lastly, we'll see how Boundary's newest features also can be used to improve this story, like Boundary's new desktop app for Mac OS, which allows low or no-code users to view what systems they can access and connect to over a GUI interface. And then also, we'll see worker tags and filters, which allow users to choose which Boundary proxy workers should manage a target's connections. This is really critical for meeting user security and latency requirements for private access, particularly if administrators need to ensure connections route through a worker that is both peered to the target private network and local to that region. That way, as a Boundary user, I don't need to route traffic through a completely different region or risk having a connection fail due to it being assigned to a worker on an unpeered network. With that, I'll pass it over to Charles to walk through the Roblox solution and give a demo.
So today, we're going to bring up a full local Boundary environment that's more, quote, production ready than a local Boundary dev, as well as being a lot more dynamic. So we're going to use this using Docker Compose. And this set of containers consists of a Postgres database, a Boundary cluster that uses that Postgres database, a container of MySQL, container of Redis, container of Consul, as well as Consul registrator to register all the services. And so what's happening here is that it comes up is that the Postgres database is being bootstrapped for use with Boundary because Boundary just uses normal everyday database migrations. So now that everything is up, we're going to apply some Terraform to configure Boundary. And what this is going to do is this is going to create local users, roles, accounts, some new auth methods, a handful of scopes, as well as OIDC users and all the configuration for it. So now this is finished. We've applied all of our static configuration. And so now it's time to get a little dynamic. So if we look at Consul, you can see that we have MySQL and we have Redis registered in here now. Right now, if we actually were to go to look at everything, we would see that Redis and MySQL aren't in Boundary right now. So let's take care of that. And with the demo luck here, you can see that we forgot the path. So going to the right path actually helps a lot here. So what we're doing is we're running Consul Terraform Sync. And what this just did was it reached out to Consul, it discovered Redis and MySQL, and then it ran a set of dynamic Terraform to introduce them as targets and host sets into Boundary. This will now happen all dynamically. So if I go in and I restart this Redis container, you'll see this is going to start to fail because Redis isn't there anymore. It doesn't exist. And when this finishes, you can see that Redis came right back up. It reached out to it. Now, because we're using Docker with a local setup, this isn't actually moving hosts. But if this were to move to a different host and get registered differently in Consul at the Redis service, this would have dynamically migrated all of this behind the scenes with no input from anyone. It's one of the cool things about Consul Terraform Sync. So we're now fully configured. So let's kind of authenticate. Let's get into Boundary a little bit here. And so today we're a new user and we don't know what all the auth methods are. So we actually want to take a look. So we can see here that we have a password. We have a couple password methods, but we have this OIDC one, which we really care about. And the way that we're going to do that is we're going to authenticate on the command line through OIDC. It's going to bring us to Azure Active Directory. We're logging in with this account here. And just like that, we're authenticated. So what we really want to do today is we want to use a bit of Redis. We've been told that it's not open to the public and we have to go through Boundary. So let's walk through what that looks like while we do a little bit more discovery along the way. So we want to say, hey, Boundary, tell me all the host catalogs. And so here we have this host catalog set in the database project. So we can use this and we can say, here's all the different hosts. So now this set was created on the initial Terraform apply, and these two host sets were dynamically created by Consul Terraform Sync. So again, we care about Redis. So we're going to say, what about this host set? Who's in it? So this is just the one host right now. And again, we're going to say Boundary. This is host. So you can see it's 172.29.02. And if we ask Docker, what is this IP import? You can see that they actually match up. So now that we've confirmed that Redis is where we expect it to be, we now want to actually connect to it. And so to do that, we want to get all the targets, and we want to say, hey, here's the Redis target, and we're going to connect to it. And what we're going to do right now is we're actually just going to straight up exec right into Redis without ever having to actually know what the port is. So in this case, it's 60962. Doesn't actually matter. So this is a brand new Redis server. We don't have everything in it. So we're going to set the foo key to bar. We're all done with Redis now. We actually want to get out of here. But just to confirm, we do have Redis listening on the host, 6379. And if you look at the keys now, you can see that we actually see that key that we just set. So again, if we go back in through Boundary, same thing. We look at the keys. There's our key. Get it? We get the same value. So this is accessing Redis, or really anything, dynamically directly through Boundary. So to talk a little bit more into the kind of CTS piece, that's Consul Terraform Sync, it's pretty cool. So we have a basic config file here, which is just your general stuff. You have some log information. You need to tell it where Consul is at. and then you tell it the providers that you want and how to configure them. As well as today this used the Terraform driver, so this has its own set of configuration where you say, hey, here's where all my syncs are going to be at, but they call them sync tasks. This is the backend I want to use. We're using Consul because we're using Consul for everything right now, as well as the providers, which again today we're using Consul boundary, as well as the HTTP provider. So this is the task itself, which again we're just calling a boundary. It's a local thing that we've written into this demo, and the providers that it's using are HTTP and boundary, as well as the services that it wants to look at, which is Redis and MySQL, as well as a buffer period. So the buffer period is really important. We at Roblox run a very large cluster. We have something like 70,000 health checks at any given point in time. And so as you can imagine, they move around a lot. And so if this wasn't set and we just let it go full bar, it would pretty much go crazy on our cluster. So we needed at least a 5-second buffer here. So outside of that, let's look in the actual Terraform itself. And so it generates some Terraform for us. This is all generated by Consul Terraform Sync. It's got some basic information here and some back-end stuff. It's just normal Terraform. And then if we look at the one level deeper, we have it in here. It's actually a very special variables file. So this is on HashiCorp Learn's website. If you go on here, you will be able to find this. It's just copy and paste. And you can actually omit a lot of this. And then if we look at the actual Terraform we've written for this is just a very normal Terraform with kind of this secret sauce being in that services variable. So for this demo, we've just mapped some services into a thing that we can consume with for each. And some of the interesting stuff in this demo is that to get all the information out of boundary to pass to the resources, there aren't data resources today for the boundary provider, but there will be in the future. So for right now, this is a lot of this kind of, we'll say, creative use of the HTTP data provider to populate all this information. And now again, this happens totally dynamically. We can go back in and we can start it right back up. And this shouldn't make any changes because it's already in sync. And just like that, we now have a fully dynamic boundary thing with Consul Terraform Sync that's hooked up to Consul, which is using Terraform and boundary. So we have a bunch of HashiCorp products kind of all talking together and working very well. So as a bit of a bonus, you can see that while I, Charles, really like command line, not every user is going to like command line. So you can actually access all of that right through OIDC, just as I showed earlier. And you can do all the same stuff that you just did. So you can connect to Redis. This gives you the information. So we're on 61057. And there's that key that we had earlier. And now, of course, Redis isn't the only thing you can do with this. You can connect over SSH. We have Postgres, Redis, MySQL. But I only have the Redis CLI installed on my laptop right now, so that's why I showed this. And you can put anything in here. You can do web applications, all kinds of stuff. And I hope that this demo has shown a little bit of the power of boundary and kind of the dynamicness that you get with Consul Terraform and Consul Terraform Sync. And so back to you, Pete.
Thanks, Charles. To close, let's talk a little bit about where Boundary is headed from here. First off, while Boundary already supports integrations with external identity providers via OpenID Connect, we think we can take this a step further by syncing group membership claims from IDPs to Boundary groups. This way, the claims managed at the identity provider level can be used by Boundary without additional configuration. Second, we'll continue to enhance Boundary's target discovery story by enabling administrators to define dynamic host catalogs even outside of Terraform and Consul Terraform sync, so that services can be discovered based on predefined rules or tags. These catalogs will be extensible via a plugin framework so that community can create their own plugins for their preferred infrastructure platforms or service discovery tools. Lastly, in an upcoming release, we'll also focus on integration with Vault or your preferred credential management solution so that you can use ephemeral credentials minted by Vault to authenticate to Boundary targets. This would enable a single sign-on flow so that those creds are obscured from end users. And in closing, as always, we'd love to invite you to try out Boundary for yourselves. Boundary is available at boundaryproject.io, and we have a whole set of onboarding docs and tutorials to make it easy to onboard. Good luck trying out Boundary, and looking forward to the question and answer period following this session. Thanks, and look forward to trying out Boundary.